right? So we were talking about the affinity. So what is affinity and how that is related to our SQL Server, or so the process that we have discussed, right? So affinity is kind of masking the number of CPUs so that SQL can see only those many CPUs. Or in other way, whenever we execute our queries, whenever we execute threads, those threads can be executed so in a multiple processors, right? For example, so we have SQL Server, and let's say I have 4 processors, right? 1, 2, 3, 4, and this is, you can consider this as a so this is the processors. So whenever 4 threads will be created at any point of time, right? So that 4 threads will be executing on the CPU at any point of time, right? So one threads executing, right? Let's say this is one threads executing, and once this come out of CPU, there are chances the same thread can go and execute on the other CPU. And if it come out of CPU, the same thread can execute on the another CPU. So that same thread can execute on this another CPU, right? So how this will decide, because of the affinity configuration, right? If you configure any particular affinity, SQL Server can start executing these threads on a different so processor every time it come out of CPU. So that will delay in execution because it has to identify the available CPU to execute, right? So it will be a performance issues as well. So another problem is, another scenario is, let's say I have SQL Server. So I have SQL Server, I have 4 CPUs. So I have 4 CPUs. I have 2 SQL Server instances, right? So these 2 CPUs, SQL Server can see only these 2 CPUs. Other CPUs cannot, I should not expose to all other SQL servers, right? I'm just restricting SQL Server to can see only few CPUs, right? Here, if you see, it can see only 2. If you have 4, it can see only 2. Let's say, for example, I'll show you how that can be restricted. But before that, let's read out this. Processor affinity mask is a way to let the Windows scheduler know the application process preference, right? Preferencing is this, right? I'm preferencing only 2 CPUs. I don't want all the other CPUs to be exposed to this SQL Server. I have 2 SQL Server instances installed on this. I want only these 2 CPUs can be visible to SQL Server. And other way, I have another 2 CPUs can be visible to this particular instance, right? That preference I can set. So these decisions are application dependent, right? So application whichever we are using, so that is dependent. We can use that either using Task Manager or SQL Server. We have that facility for SQL Server. I'll show you how to set that affinity mask or affinity, right? So the bitmap indicates the processor on which a process or thread can run. So based on settings, we will decide on which processor a SQL Server threads can execute. For example, if you see here the SQL Server, go to the properties, and we have something called processors, right? And we have 4 CPUs, right? See here. So we have 4 CPUs configured. Now, if I execute, so where we can see that sp underscore read error log, right? So sp underscore read error log, it will tell how many CPUs I can see. This is the overall CPUs. Another query that I can see is a scheduler. So I will talk this more. Sys dot dm underscore os underscore scheduler. This is the DMV to identify how many CPUs that the SQL Server can see. See here, visible online, visible online. Whatever the status is visible online, we call that as a CPUs which SQL can see. Right, so this is visible online. This is for dedicated administration connection, DAC connection. There are few hidden schedulers will be created for some few tasks, like backups, right? So backups will not run on the visible online scheduler, so that will be running on the hidden schedulers, right? So SQL backups, whatever backups we have, that will be running on the hidden scheduler. So we will not come, we will not so go into that, but for now understand that we see 4 CPUs here. Let's change the affinity to 2. 1 2 0 1, right? So if I execute that, so this is a on fly, so we no need to restart the SQL Server to change or configure the affinity mask or affinity settings. This is a in-flight so operation where it affects immediately without any a restart of the SQL services. Let's execute the same. Now understand, these are the 4 online CPUs. Now execute the same. See, visible offline, right? Visible offline, where the threads will not be executed on this offline schedulers, right? So we are restricting to run only these CPUs, right? For example, let's consider right. So let's consider SQL 2019 or 2017. Go to the properties, processors automatically. So I don't want to set anything for IO affinity. So IO affinity is the same, right? So IO affinity. So there are some IO threads, IO operations. Let's say, for example, lazy writer or checkpoint or any IO operations will be performed. So we can have a configuration. At any point of time, we can restrict only one. For example, if you use this, if you remove this, if you want to restrict IO affinity, you cannot restrict CPU, right? So basically what we are doing, IO. So IO, we are restricting to execute only on particular CPUs, particular CPUs. IO threads, we will talk more when we talk about um, so what kind of threads we have, and also we will talk about what IO threads we have, right? But for now, understand that. So this IO affinity will let few threads execute on the CPU, right? So it will not let all other threads to execute on the CPU, right? So now I'm restricting only the last two to visible, right? So same query, if I execute here, right? See here, visible online, visible offline, right? So likewise, we can restrict which CPU can be visible on my to my SQL Server. But it is ideal, or it is better not to restrict this affinity unless and until it is required, or if you have high CPU count, let's say for example 32 CPUs or 64 CPUs, or you have a high number of CPUs, better not to restrict, right? If you have high CPUs, that is okay to restrict, because whatever CPUs you require, that will be taken care. But if you have so one point here, see here, we got an error, right? Why that error? The affinity is set to manual, right? So the affinity is set to manual. I have just removed this checkbox, right? Automatically set the processor. If you set automatically, all the processor will be automatically configured, so that SQL can See, if you remove that, you will have to select. Either you can select all or you can select whatever you want. Right? That is the reason we got the error. So I just selected all to execute. So this is how you can see. If we just execute, you will see all, right? All CPUs. And if you offline, you see, right? So if you execute, you will see all the CPUs are visible so that all 4 CPUs can be scheduled. We can run or threads can execute on all 4 CPUs. So what is a quantum? So quantum is one word. It will decide by the operating system when the thread should come out of CPU, right? So in before example, we discussed about yielding, right? So when the thread will yield from the CPU. For example, in a group discussion, they given only 5 minutes. I mean, 5 minutes is very high. For example, let's say they have given only 1 minute or 30 seconds or 45 seconds time for you to discuss, right? So you will have to complete, or you'll have to have complete or yield within that particular duration, right? So if you're not yielded, then someone will kick off, right? The same way, quantum is a so time slice, how much time it will decide, operating system will decide how much time, how much maximum time the thread can execute on the CPU. If it is more than this, or if it is reached that time slice, then it will be kicked out of CPU, right? This is the time slice. A thread is given to run by the Windows scheduler, right? So scheduler is nothing but your CPU. So Windows creates a illusion, right? So that all threads run concurrently by partitioning the time, right? So time, each thread is allowed to run into time slice called a quantums, right? So it hands quantum to thread in a round robin way. I'll explain that. What does it mean? Right? This is your process, like whatever process you consider, this is your process. We have multiple, so task 1, task 2, task 3, task 4, task 5, task 5. Likewise, we have multiple tasks, task n, right? So this is a layer where we have multiple threads, right? So a process will not execute, threads will execute our task, right? This will be created. Each task will be assigned to a single thread or multiple thread. It depends on the multi-processing, like parallelism, right? This thread will be assigned. So another thread will be assigned to another task, and these threads will be running on the CPU. So this is the CPU 1, CPU 2. Let's say I have 3 CPUs. Let's consider I have 3 CPUs. So how this task, let's say for example, I have 20 tasks, and these 20 tasks will be assigned to 20 threads, right? Of course, we will talk, so multi-threading and multi-processing afterwards. But for now, understand that we have multiple tasks created, and each task we require one thread, right? So a total of 20 threads it will be created, but I have only 3 CPUs, right? So how these threads will be executed on the CPU? These threads will be evenly round robin way. It will be distributed. For example, let's say first task will be assigned here. Second thread will be assigned to here. Third will be assigned to here. Then again, that is fourth one, fifth one, sixth one. Next, seventh, eighth, ninth, right? Likewise, it will be assigned in a round robin way. Round robin is nothing but first one it will assign, second one here, third one here, fourth, fifth, sixth, seventh, eighth, nine. Let's consider we have 9 here, 10 here, 10 here, 19 threads, right? So if a new thread comes in, then it will be assigned to wherever we have a less number of threads. So I will talk where these threads will be waiting, and if only one thread executes, what will happen to all other threads which are in the line, right? I will talk about it. But for now, understand that quantum. Now, one thread is running here, then it should come out of CPU and it should allow other thread to run on the CPU. Once that quantum is completed, then it should come out of CPU, then other thread will come out of CPU. So what is the quantum time is 4 milliseconds, right? 4 millisecond is the duration of the quantum. If the thread is executing more than 4 milliseconds, then it should come out of CPU and it will allow other thread to run on the CPU. And remember, this 4 millisecond is a Windows level quantum, right? What is Windows level quantum? SQL is not decided this 4 milliseconds. That is the reason, if you remember, if you see any queries which are running for longer, because of this. So if that is the case, then it should complete, or it should come out of CPU every 4 milliseconds, right? It is not coming out of CPU because of this is a Windows concept that is developed in the Windows operating system. So I will talk like how we leverage this feature, right? How we use this feature, and so how we overcome this, we will discuss more in detail. But for now, understand a quantum is a time slice, that is 4 milliseconds. If the thread is reached this 4 millisecond, it will come out of CPU and it will allow other thread to run on the CPU. That is quantum, right? So that is what the second point is. It is an illusion that all threads run concurrently by partitioning the time each thread is allowed to run into the slice, into the time slice called a quantum. That is a 4 milliseconds. Now, understand the same logic. I'll open a new one. So if you have any questions, or if you feel, so anything like uh, not understanding or boring, just let me know. We'll discuss further. Any questions?
Yeah, Chandu, can you repeat that round robin? Because I have been asked in interview what is the round robin concept. So I did not say. If I search in Google also,
Hmm.
I don't have a proper knowledge on that.
Okay. So round robin, I don't know what sense they asked you, but in a just simple
They are
terminology.
okay. They have asked me like, uh, see if one drive is getting filled,
Hmm,
so how will you add the another drive? So in the same sense, you should be used round robin method. So I did not understand the question what the way he has asked. So
hmm,
how you will attach the drive on how what is round robin like that he asked me,
hmm,
which
hmm.
is related to like that.
Okay, sure. Just a moment. Okay, sure. So round robin is nothing but equally distributing your load. For example, I have explained this. Yeah. So let me explain this way. Right. So I have 1, 2, 3, 4, right? So whatever it is, like 4 threads or 4 so tasks are created. So I have 2 CPUs. Let's say I have 2 CPUs. So 2 CPUs I want to allocate these threads to the CPU, right? So that these threads will be executed. And how that will work. So let's say, for example, first 2 tasks I cannot assign here, right? Or likewise, equally cannot be distributed, because we don't know like how the workload, how this works, right? One query can execute very fast, or second query can execute it's in a small duration, or first query can utilize all the resources, or second query has to wait until it's completed. So we don't know how that works, right? So instead of allocating so whatever we like, instead of that, what we will do, so first thread will be allocated here. So it's a second thread will be allocated to next available one. So if another one is available, third one will be assigned to the third CPU or next one, right? Let's say, for example, now I have only two. Next, two are pending. So first one allocated to first one, second one allocated to second CPU, and third will be allocated to first CPU. It's a round robin is nothing but in a circle, it will be allocated one after another. Fourth one will be allocated to here. So if you have fifth, sixth, something, fifth or sixth or seventh, so it will be allocated in the same way, right? Fifth will be allocated again to the first one, sixth will be allocated to second, seventh will be allocated to first. So this is the equal, or so in a sequence it will be allocated one after another to the available I would say, like, so available CPUs to distribute the load what we have. So we are distributing load equally, right? We are allocating one to one, so to the next CPU. So this is what we call it as a round robin. So we are allocating or we are distributing the load equally to all the resources we have. Is it clear?
Yeah, okay.
Yeah, so this is so as simple as this. But so I don't know like what sense they ask, maybe if you adding multiple disks. So for example, let's say so if you add multiple disk, so one like for example, if you're using any routing, so load balancing, so load balancing kind of thing, so it can load, it can so go from, I mean, it can evenly distribute the load in this such a way. For example, let's say you have always on read-only routing with load balancing starting from 2016, right? So how that works, the same way. So it will distribute in a round-robin way to reduce the load, right? So let's say, for example, you have one replica here, one replica here, one replica here. So if you create multiple sessions or multiple threads, it will be allocated one after another, the round-robin fashion, so that to distribute the load on your servers,
Yeah, okay, Chandra. Thank you.
right? Now let's say this is a quantum we were talking about, right? So this is a CPU, right? So I have two CPUs and I have created four threads, 1 2 3 4. So these two threads, let's say for whatever reason, whatever it is, like let's say two threads are executing, two threads are assigned to CPU, right? So one thread execution is completed, it should come out of CPU. I mean, one thread is completed its quantum, right? 4 milliseconds is completed. Then it should come out of CPU. 4 millisecond is completed, then it is come out of CPU. Once the second thread executes, then it also should come out of CPU once 4 milliseconds is completed, right? So this will come out of CPU once 4 milliseconds are completed. Then what will happen? Whatever threads which came out of CPU, let's say I have only 4 CPUs. I don't have any more threads or any more. Sorry, I have only 4 threads. I don't have any more threads. I want to execute only 4 threads. And if no other new threads are available to execute, then what will happen? The first thread again should execute on the CPU, right? So first thread should execute on the CPU again for 4 milliseconds. Now, what will happen until this point? Let's say 4 milliseconds, it has done 1000 reads. Then it come out of CPU. 1000 lines it read, whatever it is. Then Again, if it executes on the CPU, it should not start from the beginning, right? So it is already done some work. It should not start from the beginning of its execution. It should start where the execution is left, right? It should read from 1001, right? So it should not read where it left. It should not read from the beginning. It should read where from the thread left on the CPU, left from the CPU. That is what we call it as a context switching. So this thread context, whatever it has, the register, I mean, so there are some internal structure, internal information of this thread will be stored somewhere, right? So this stored somewhere, that is what we call it as a context. The context of the thread will be stored somewhere. Whenever it again the thread loads into the CPU, that will read this context, understand that where it left, and start executing that point. Saving information for old threads, loading information for new threads, right? So that is your contexting, context switching, right? Whenever it come out of CPU, the information will be stored, and whenever it is executing on the CPU, the context will be loaded and it will be executed on the CPU. That is what we call it as a context switching of your threads, right? So these are few terminologies like multitasking and multi processing. Multitasking is nothing but so multiple programs, like say for example you have notepad plus plus notepad.exe, right? You can open and operate, like so more than one programs at a single point of time, right? That is called multitasking, right? You can open and you can work on multiple tasks or multiple programs at the same time. We call it as a multitasking. So multi-processing is simple words, processing your task, right? For example, let's say you have a process, you have a executable, and processing your task on multiple CPUs. It is called multi-processing, right? So in simple words, we call this as a parallel processing, right? So we have parallel parallelism and also that and all we have, right? So that is what we call it as a multi-processing of your application or your code, piece of code, right? So this is a multi-processing. So this is just so understanding of Windows CPU architecture. This is not needed, but for now just a high level overview how it looks like, right? So this is the high level overview how this CPU so we have. So initially low level we have something called right? So it's not actually low level. We have a multiple CPUs is combined called a NUMA. So we will discuss more about NUMA and memory later. For now, understand only this piece, right? So socket is nothing but a we have something called so motherboard. So to the motherboard in the CPU, we will have some kind of chip, right? So we are not going into that socket. It is a Windows area that we have, and each socket can have one or more number of CPU cores, right? So one or more CPU cores. CPU core is nothing but a pin that is allocated to socket. So it is a physical core of your CPU, physical CPU, right? So this is your CPU. So one socket can have one or multiple CPU cores. At the same time, each CPU can have one or more than one logical CPUs or logical processors. If you see here, or if you see, yeah, let me open the GUI. That is better. So I have one socket. Each socket I have one core allocated. You can see here. Sorry, fine. So the logical CPU, logical processors, I have four, right? What does it mean? I have four cores. I have only one socket. I have four cores as allocated to this particular socket. This socket, I have 4 cores allocated, right? Likewise, I have 4 cores allocated in my mission. This is one configuration, and this is each core is allocated to one CPU. Each core is allocated to one CPU. This is how the configuration is. So in this architecture, we have around 16 CPUs and 8 cores, right? Each core has around 2 logical processors. This is a NUMA node. NUMA is non, we will discuss more about NUMA in memory architecture. For now, understand that NUMA is nothing but a collection of more than a collection of one or more than one CPUs is called a NUMA, right? Here we have around 8 CPUs logically grouped together and considered as a NUMA, right? So to configure NUMA, we should have all these to be enabled, right? So I mean, we as in like we will not enable, it is a uh, like a processor level or CPU level or hardware level, which will be allocated or enabled, right? See here, 0 to 7 grouped to a single NUMA. The remaining all are grouped to another NUMA node, right? So this is a high level mapping between SQL Server and a Windows operating system. So what does it mean? So we have 4 CPUs I have shown you, right? So we have, these are logical CPUs from the SQL Server perspective. It will be mapped one to one to the physical CPU. See here, this is a scheduler 0. So we call it as a scheduler at the in the SQL Server. CPU 0 and scheduler. It is a one-to-one connection. So how this works? Sorry, how this works? Whenever a thread created, it should execute on this CPU. Whenever a thread created on this scheduler, it will be executed here. Whenever thread created, it will be executed here. So likewise, it will have a one-to-one relationship of your scheduler and CPU. So scheduler is at the SQL Server layer or SQL Server level we have, and CPU is at the Windows level where we have a one-to-one mapping here. Right. So any questions so far? Right. So is it interesting, or you feel it is kind of so boring or something?
We are good. No worries.
Good. Okay. So Windows, so there are two, so concepts. Because of this, a SQL OS has been introduced, right? So we have Windows operating system. Why we need SQL OS, right? So we have Windows operating system. So when we have Windows operating system, why we have so why we have SQL OS, right? So we can use Windows operating system itself, right? Why we need additional feature or additional so work to SQL Server developers. I mean, so SQL Server developer as in like not individual organization developers. SQL Server.exe who has written. So those developers, why they want to so introduce a new concept called SQL OS, right? So this we are going to discuss. We have something called preemptive versus non-preemptive scheduling. So what does it mean by preemptive and non-preemptive? Preemptive, I told you, right? So the thread will come out of CPU. So when the thread will come out of CPU, uh, what is preemptive scheduling? Advantage and disadvantage we will talk about. Preemptive, it will come out of CPU on its own, right? So we will not let other threads to uh, yield. For example, let me put this way. So again, this is the CPU and this is scheduler. And if you have multiple CPUs here, two, three threads. Three threads. We have three threads on each scheduler. So one thread is executing, it should come out of CPU and it will allow other thread to execute, right? So when this thread will come out of CPU, once the yield point, once the yielding happen, once the quantum is completed, right? So preemptive scheduling at interval level, that is every 4 milliseconds. For example, that is 4 millisecond is completed, right? So that is one, when it should come out of CPU. One is 4 millisecond yielding, 4 millisecond completed. The thread will yield out of CPU. Second scenario, let's say uh, thread, they have their own priority to execute. Priority is nothing but, let's say we have total 32 priorities. I'm not going into it. 32 priorities, 32 priorities, where it's a range of priorities will be allocated to individual process or whatever, right? So if high number of, let's say the thread which is running here is a low priority, let's say priority level 7 or 1 to 7 is a range, so we call it as a 7. Let's consider priority 7 and another thread with high priority, priority priority 10 comes in, high priority, right? So if we have high priority, what will happen? Whatever thread which is low priority will come out of CPU. It will allow high priority thread to run on the CPU, right? Right. So if high priority thread comes in, so it will allow the thread to run on the CPU, so that the current executing low priority thread will come out of CPU. If you talk about SQL sense, if you see so sp underscore read error log, SQL is using a normal priority, that is your 7, right? So SQL using normal priority, that is your 7. So you must have heard like deadlock scenario, right? Deadlock, so transaction deadlock. So if you set that whatever victim thread to low priority, then that will be kill, like, so that we will talk about later, more about later. But for now, understand that priority driven, priority is nothing but if high priority comes in, low priority thread will come out of CPU and it will allow high priority thread to execute on the CPU, right? So third